Alright, so I'm back. Let's go check out and see if that event handler is there. So I'm over here, I'm going to refresh, and we're really not going to see anything unless we have the console open. So I'm going to open up the console, and we have a lot of real estate here. So I'm going to actually do that. Actually, that is not too bad. That's nice. That's nice. Okay, so let's click here. Excellent, excellent. So we're seeing some feedback. We are actually getting that mouse event, and we got all this stuff. This is another reason why I want to make my own event object, because there's all this stuff, and I don't need all of this. I do not need all of this stuff, right? And if we were to try to port some code to my C code base or whatnot, I don't want to have to transcribe all this and use all of this, right? I'm not going to use all of it. So I just want to create these adapters so that I can kind of whittle down the problem and get rid of all of this stuff that I don't need. It's kind of like you know how in story problems where they say a whole bunch of irrelevant details that you're never going to need just to confuse you? That's kind of how I see all of this stuff. There's a whole bunch of stuff, and I'm not going to use it all. Okay. So let's take a look over here. So how do we get this mouse X and the mouse Y in terms of where we are clicking on? Do we want where we're clicking on the canvas, or do we want where we're clicking on the viewport? Well, I would say it makes most sense to... We eventually want to know where we're clicking inside this viewport, but it makes more sense for the event here, for this event object, to be loaded with where you are clicking on the canvas rather than where you are clicking in the viewport, because I don't know, that just, to me, I'm bad at explaining why we should do it that way and not the other way. But let's just get at it. How are we gonna get from that event object? How are we gonna extract that? Well, first of all, I know I have one of these instances, this global event object. I have one of them as a member of our global data. So global data.global event, right? Okay. So let's get the global event object. Var global event equals global data dot global event, right? And global event dot mouse X equals to do, and then we want the mouse Y, and this is a click handler. So because this is a click handler, we actually want click X, click X, and click Y, CX and CY. And then eventually we're going to have another handler that we add that's going to be a mouse move handler for the M and Y. And how do we calculate that? I know I have some code somewhere, or I've done this before. So let's go find that code, because okay, let's just go find it. So I'm gonna it would be in a... So I'm gonna take this add event listener, and I'm gonna copy that onto my clipboard, and I'm gonna search one of my code bases that's also JavaScript, and I'm gonna find some code for that. So find all, and now I can see where I've added an event listener, and I see one of these says canvas click function in all capitals, and I'd say that that sounds about right. So canvas click function, where are you? You're down here. It looks like we have some code that looks like we get the canvas X, the canvas Y. Alright, so there's a little bit of code here for get bounding rect, and then client X, client Y, and then that rectangle. Basically, I believe it's the what we're doing is the event.clientX is like where your click is in the entire screen, and then you have to subtract how far away the canvas is from the origin of the screen to get coordinates that are local to the canvas, right? So if the canvas is at 0, 0, then if you click at client X and client Y at 100, 100, right? Well, since the canvas is already aligned with the client, then it would be -0, -0, right? And they would be the same coordinate. Now, if your canvas is offset 100 on the X, then if event.clientX is 100, right, then that would be the origin of where your canvas is. So event.clientX 100 minus where the canvas origin is, right, the dot left, and that's also 100. So 100 minus 100 would get you 0 in terms of canvas coordinates, right? Like if the canvas was offset 100 pixels in the client area. So how much of this code do we want to take? It looks like the CX, the CY, the current. Okay, the current event. So I guess cur I'm using for like a current event type. I think I might have been a little bit too granular there when I did that. Type of canvas. Interesting. Okay, so we'll take all of this, and I really don't care about that type of check. There's probably a reason why I did it in that code, but let's not worry about it. So let's we're just pasting this here, and global event.cx_cy, so that's cx_cy, canvas X, canvas Y. This all lowercase thing is kind of ugly. Whatever. It's probably best not to, unless I have like unless I think really hard about what I want this variable name to be. It's probably best that I don't change it, because the less I change of this code that I've just cut and pasted, the better, because now I can possibly find its origins, like where I cut and pasted it from again. But, you know, if we come up with some better names for this later, we can refactor that. So cx_cy, we can take this note here and we can just paste that right there. And you know, sometimes I like to add more indentation than is actually necessary. Just to say that if you ever use like a with statement, maybe you could think of it like that, but the idea is that for this global event variable, like all of this code in here is relevant to this variable, and that's kind of why I'm like indenting it like that. So this EVT here is actually going to be the native event that I logged. So let's go replace that like that. Let's line some things up a little bit. And rectangle canvas. So canvas is an underscore canvas. And we don't have the canvas here. We have it as a... we got to store this somewhere. So let's make... what I like to do here is have a variable called underscore. equals object. And so underscore is, you know how like private variables, one common convention is that private variables start with the underscore. So what I like to do is just create an underscore container, and that houses all of the private variables. So I can do something like underscore dot can, and then I'll just set it to null right there. And then you know, we can do something like p for private. Okay, so p for private variables. Okay, and so this canvas here, we're going to check to see if it is actually valid when it's supplied to the constructor. And then if it is, we're going to do underscore.can equals can, like that. And so maybe you see the reason why I use an underscore object. It's because if I double click that, I can kind of see all the references. Whereas if this was just underscore like that, then when I click that, right, this one doesn't get highlighted. And I like to be able to quickly see all of the connections of where everything is connected just by clicking really quick. And I can see all those connections. Okay, so now that we have the underscore canvas like that, we could probably do underscore for some consistency. We can do underscore.canvas here as well. And the constructor, that's just taking the normal input right here. And what else? So this right here is what we wanted to change. This one is going to be underscore canvas like that now. And what else? Instead of logging this native event, we've already done that. We've seen that it works. We want to console.log the global event object and see what we get. Okay, so let's take a look at that, see if we screwed anything up. We'll refresh. We'll click. Okay, global data is not defined. So why is that? Okay, so I think we coded ourselves into another dependency loop kind of thing. So I might have to think a little bit harder about how I'm structuring this code. So global data dot global event right here. And I'm going to guess that when I create this singleton, right, I create it inside the global init, right? Yeah, so I do. So one way I find that really helps when trying to reduce the amount of dependency loops you get is to separate your data from your functions, which is a very procedural thing to do, right? Separate your data from your functions. But the thing is it just can solve. A lot of times when you're writing your code, you get what I would call artificial dependency loops. It's like it's a dependency loop because of the way you wrote it, but there's no real inherent dependency. It's just you've coded it in such a way that you've created a dependency that doesn't really have to be there. And a lot of those artificial dependencies can happen when you tightly couple functions and data together. You can create these dependencies that just don't have to be there. So as I'm looking at this, I've already called this object global data. Okay, it's called global data, but these guys here are objects. So it's not really data, right? An object is kind of like data and functions mixed together. So really, I think what I should have is since we do have some object-oriented things and we can't un-OOP ourselves, I'm going to have, I think, global data. Then I'm going to have global functions, and then I'll have like global objects. Right? So the global data is just data, global functions is just functions, and then global objects means that they are some type of thing that is a mix of functions and data, right? So when I've been talking about making these classes, right, so our user input adapter singleton, this is an object, right, because there are functions in here, but there's also variables, right? So here's a variable, but then there's also functions like native click event handler. So when you are setting all your code up, when you're initializing your library, you want to initialize the data first, then the functions, and then the objects. Because of how functions are kind of registered in JavaScript, you don't really have to worry about the function order, like where functions is initialized. But if it was C code, it would be data, then the functions, and then if you have some weird concept for object, that would be next. If you're using some type of object orientation pattern, right? Like OOP is actually a pattern. You can do it in C code if you want to. But yeah, so let's get to refactoring that. I want to have a sanity check, make sure the same things are broken as I just saw. So I'm going to click here. Global data is not defined. Okay. So global data dot global event. So this is, hold on. So this line right here, line 101, that is written as it should be. It's just that this user input adapter singleton, it really should be in the global objects container. So let's do that. So init global data, and where are we returning this? That's actually kind of bothersome. I know I refactored it. So global data is inside of main. So I don't want to call this at file scope, but I actually do want this variable global data to be declared at file scope. So I want to change that like that. And then I want to go out here, and then go up here, and I'm gonna do GW global whatevers, and then var global data equals null. Alright, so there's a reason why I want this here instead of in this global data section, because I'm also going to group this with global data, global func, and then global objects, like that. That looks kind of ugly. Global data, global func. Okay, we're going to do some abbreviations. We're going to change this around a little bit. We're going to make some comments here. Global functions, and then global objects. Okay, so data, functions, and objects in that order. And then an abbreviation I use a lot is DAT for data, fun for functions, and then obj for objects, and then over here, calling it GLO like that. So we got these global containers. And so obviously I've broken some more stuff, and we're going to have to fix that. And so my time's almost up, so I'm going to stop recording and start another video.